Hello, my name is Katarzyna Wawrzynek and I work as a software tester at Nice Project. Today I am delighted to share with you one of my projects, the RDP Connection Service. But first I would like to introduce myself. My journey to become a software tester was not an easy path. I graduated in chemistry and started my career in the research and development department at one of Nestlé's factories, where I worked for 5 years. However, life had other plans for me, and a significant turning point occurred during my maternity leave. It was during this break that I made the decision to choose a new career path. In September 2021, I joined the QA team at the Nice Project company. In this role, I had an opportunity of working on various projects, using technologies such as Python, Selenium, Robot Framework, Ranorex, and also managing CI/CD pipelines. Let's now move into the main topic of my presentation, the RDP Connection Service. In the center of our concept lies a desktop application. Our goal is to test desktop applications using our primary technology stack. In other words, we intend to automate tests for desktop applications using Ranorex, Robot Framework, and GitLab. Ranorex is a commercial test automation tool designed for desktop, web, and mobile applications and is dedicated for Windows. Its main product, Ranorex Studio, enables you to write tests using code, record actions, or utilize both methods, and also provides an easy-to-use tool for object recognition within the application. To write Robot Framework tests using Ranorex methods, we have developed a custom Robot Framework library named Remote UI Library, which I will discuss shortly. But the key point here is our need to execute tests within GitLab pipelines. Let's picture this scenario. We have virtual machines on which we intend to test various desktop applications. We can install GitLab runners on this machine and simply execute our tests. However, there is an important point to remember. As we are testing graphical user interfaces, we require a screen or its virtualized display to interact with desktop applications. This means that we need a physical computer with a connected screen as our runner. Yet replacing all virtual machines with physical ones isn't a possible option. So our solution involves using a single physical machine with a monitor capable of connecting to all the virtual machines through an RDP session. RDP stands for Remote Desktop Protocol, and it is a secure network communication protocol offered by Microsoft and is available for most Windows operating systems. RDP allows users to connect to and control a remote computer over a network connection. The key aspect of the Remote Desktop Protocol is that it transmits the graphical user interface of the remote computer to the local system. This means you can interact with the remote computer just as if you were using it locally, including running applications, opening files, and navigating the desktop. To start RDP session within our Robot Framework code, we utilize an RDP service. Our RDP service, known as NiceRDP, is an API service that can be installed on any physical computer. Once launched, it allows the creation of RDP sessions with specified machines. Here, I would like to take a moment to go back to the Remote UI library. Some of you may recall our colleague Krzysztof's presentation from last year's Wrobocon, titled The Tale of Continuous Research. It was a story about the evolution of the Remote UI library. But during the time when Wrobocon 2022 took place, The remote UI library was known as the Ranorex driver library and was designed to work with the Ranorex driver. The Ranorex driver is an application that enables testers to automate Windows desktop applications by connecting to the Selenium WebDriver. So testers experienced in Selenium WebDriver could automate desktop applications without needing to learn new tools or languages. Since last year, we have written many tests that use the Ranorex driver library. However, we soon noticed that the Ranorex driver offered a limited number of methods for automating desktop applications. So finally, we made the decision to revert to one of the previous library versions. So the current library is called Remote UI Library and is built on top of Python, Python.NET, and Ranorex.NET libraries that are directly imported in the setup of the Remote UI Library. Now I hope you have a better understanding of the Remote UI Library, which is an important element of our solution. But if you need more, and if you are interested in following the entire story of the continuous research of our Ranorex-based library, I encourage you to visit the Wrobocon channel on YouTube. Next, I would like to explain the architecture of our solution for testing desktop applications. In this explanation, I will walk you through the steps performed in the GitLab pipeline. When the GitLab pipeline is triggered, a non-interactive session is initiated on the test machine. The test is then started, and in the test setup, a post request is sent to NiceRDP to initiate a remote desktop connection with the test machine. Next, an interactive session, so the session with the display, is launched. When the session starts, it triggers a task in the task scheduler to launch the remote UI library on a remote server. Now, Robot Framework calls keywords from the remote UI library and the test case is executed. Once the test case is finished, during the test teardown, a delete request is sent to the NiceRDP service to terminate the connection with the test machine, and the interactive session is closed. After the test teardown, the non-interactive session is also closed, and the entire pipeline job is finished. In this step, we have understood the position and role of the RDP service within the entire solution for testing desktop applications. Now, I would like to shift our focus to NiceRDP itself, exploring its technology and functionalities. The NiceRDP service is written in Python and utilizes the Fast API framework, which enables to build APIs with Python. Additionally, we use Wrobocon as a web server and SQLite to create the database. As part of our approach, we have also developed a separate small robot framework library called NiceRDP Manager, designed to easily use NiceRDP methods. The RDP service is stored in the Nexus repository, and it can be installed from there using the pip install command. Once installed on a physical machine, a task can be added to the task scheduler to run the service on system startup. When the service is launched, a database is created based on the configuration file. The database is simple, consisting of 3 columns, with process name, process ID, and status. Within the configuration file, we store a list of computers and the path to which the database should be saved. Computer short names are used as process names in the database table. Our RDP service offers 5 methods. The response body that is now displayed on the screen is the result of the list possible connections method. This method returns a list of all computers with which we can establish connections, along with their process IDs and connection statuses. The same information, but for a single computer, we can obtain using the getConnectionStatus method. When we add a new machine to the configuration file, we need to execute the reload service call to update the database with the new computer. Additionally, we have two methods that can be used to control connections: create connection and drop connection. The create connection method requires a username and password to establish a connection with the machine. These credentials are then saved using the cmd-key command. When the test is completed and we execute the drop connection method, the credentials are deleted and the RDP session is terminated. Additionally, at the beginning of each method, a process validation function is executed to verify all process data. This function iterates through all processes and checks if a given process is still active. When a process is no longer active, it removes the process ID from the database and updates the status to not active. It also verifies if the given computer is available in the configuration file. If not, it deletes the computer from the database. Now let's revisit the architecture diagram and take a closer look at some elements of our solution. I have already mentioned the NiceRDP Manager library. This library is in fact a robot framework resource file and should be imported using the resource keyword. In the example, you can see a simple test setup and teardown that utilizes the NiceRDP Manager resource. While in this example, I've placed the username and password in the variables section, in our projects, we typically store them as GitLab variables. Inside NiceRDP Manager, we use Robot Framework Request library. Initially, we send a request to the RDP service and then ensure that the request is successful. As you may recall from the architecture explanation, when the RDP session is initiated, the task in the task scheduler is triggered. This task launches the remote UI library on the remote server. But how can we ensure that the remote UI library is successfully started? For example, we can use a retry mechanism with a try except clause. We establish a connection to the test machine, and in the try section, we attempt to import the remote UI library. If the library is available, we can proceed with the test. If not, the except section is executed. This involves dropping the connection with the test machine, relaunching it, and retesting the import of the remote UI library. After confirming that the remote UI library is successfully launched, we can access its keywords by importing the library as remote. In the example, you can see the correct import of the remote library with default values for hostname and port. We started from the initial idea and we created the NiceRDP service to address our needs in the field of desktop application testing. We developed an easy-to-use and functional service that can be installed on any physical Windows machine, enabling the management of RDP sessions. We have also integrated this service into a larger solution for testing desktop applications. Currently, we are using this solution in several projects, and we are working on setting up pipelines that can be run on a schedule. So we consider the NiceRDP service a successful and valuable project, but there are still some plans for the future and work to do. Firstly, we want to implement a retry mechanism that prevents the creation of multiple connections to the same machine, while allowing for connection retries in case a machine is already in use. Secondly, we want to explore options related to AWS. AWS does not offer machines with a physical screen, which is essential for testing desktop applications. So we need to explore ways to run GUI tests on an AWS environment. That is everything that I've prepared today for you. Thank you for your time, and I hope you enjoyed my presentation. If you have any questions related to my presentation or any other robot framework topics, please feel free to contact me at my email address. Thank you.